Page 1 and 2 of Chapter 9, Non-Right Triangles. The formula for the area of a triangle is 1/2 base times height. If we do not know the height, what information is sufficient? Well, as we learned in the investigation, if you have two sides and an angle, then you can figure out the area, right? So, and it has to be the included angle, which means the angle that is between the two sides that you know. So the included angle. If you don't know any angles, how many side lengths do you need to know? You need to know 3 side lengths. Okay. Label the sides and angles of the triangle at the right, ABC and capital ABC. Well, the capital ABC, these are angles, okay? And small ABC, these are sides, okay? So let's first mark the sides, ABC. It doesn't matter where you put it. Now, when you put the angles, there's specific places where you need to put it. For example, the angle capital A goes across from the side called small a, okay? And the angle capital C goes across from the side that's marked small c. And the angle capital B goes across from the side marked small b. Okay? All right. Given the formula of the area, give the formula of the area if you know small a, small b, and capital C. And this is from our investigation. The answer is 1/2 AB sine angle C. Okay? Let's move on to the problems for today. Find the area of, and they give us an angle 40 degrees, and it's the included angle between two known sides. So we could use the formula here. The area is equal to 1/2 small a small b times the sine of capital C. So AB would be 9 times 10, and sine C would be the sine of 40 degrees. Okay, so to do this, you need to put your calculator into degrees mode, because we're going to do 40 degrees. And then we quit, and then we do 1/2 times 9 times 10, that would be 90 actually, and then we multiply it times sine of 40 degrees. And they know it's 40 degrees and not radians because we changed the mode to degrees. So the answer is 28.9. Okay. And then what about this one? The included angle is 2/3 pi. So the area would be 1/2 times 10.2 times 6.4 times the sine of 2 pi over 3. Sine of 2 pi over 3. Now let's draw in the unit circle. 2 pi over 3 would be this angle here, and the sine would be square root of 3 over 2. So this would be square root of 3 over 2. Okay? And then you just multiply that out with your calculator. Alright, number 3. A parallelogram has two adjacent sides with lengths 4 and 6 respectively. Let's see, so a parallelogram normally looks kind of like that. And so let's say it's got a side that's 6 and a side that's 4. If the included angle measures 52 degrees, find the area of the parallelogram. Okay, so let's see, 52 degrees. So now would that be this angle or would it be this angle? It would be what they call the acute angle, not the obtuse angle. So that would be 52 degrees here. Okay, and it says find the area of the parallelogram knowing that this angle is 52 degrees. Now, we don't know the formula to find the parallelogram, but we do know the formula to find the area of a triangle. So let's find this triangle, and then we just double it to find the parallelogram. So that would be 1/2 times 4 times 6 times the sine of 52 degrees, which we can find with the calculator. Okay, and so we want to double that, which means these cancel out, so it's 24 sine of 52 degrees. Okay? All right, let's move on. Find the area of a regular hexagon with sides of length 12. So a regular hexagon looks kind of like that, and you can even divide it up into triangles, which probably you need to do for this problem. Each side is 12 centimeters. So what is the area of the whole thing? Well, one thing we could do is we could calculate the area of one of these triangles, and then we just multiply it times 6. So let's see, what is the area of a triangle that's 12, 12, and 12? Well, since it's an equilateral triangle, we know that one angle is 60 degrees. So we could use the formula 1/2 times 12 times 12 times the sine of 60 degrees. The sine of 60 degrees, if you draw a unit circle triangle, is going to be square root of 3 over 2. So you get 1/2 times 12 times 12. So it would be 72 times square root of 3 over 2. Okay? And then you would need to multiply that times 6, because we need 6 of these triangles to get the entire hexagon's area. Okay. Number 7, a regular pentagonal guarded plot has center of symmetry O and an area of 338 meters squared. Find the distance OA. Okay, so in this case, we know that this whole thing is 338 meters squared. Find the distance OA. It wants to kind of know this. You can't call it a radius, but it's like a radius, right? So each one of these triangles, let's see, has, can we figure out the measurement, the angles of these triangles? We can at least figure out the middle one, right? Because we know that the whole thing is 360 degrees, and if you divide into 5 equal parts, then you're going to get that. So 5 equal parts, 360 divided by 5 equal parts will give us 72 degrees, I think. So that means that this angle here, if we think about this triangle here, we draw this triangle right there, and this angle is 72 degrees, right? And then, so if this angle is 72 degrees, we can figure out the other angles, but I don't think we need to. Okay, now we just need to say, hey, each one of these pink sides is, let's call it distance OA. So we have distance OA times distance OA, 1/2 times distance OA times distance OA times the sine of 72 degrees. And we know that the answer to this multiplication is going to be 338 meters squared. So now you can just use algebra, right? Because you have 338 equals 0.5, 1/2, and you have x, OA, we're going to say it's x squared sine 72 degrees. Okay, so you can use the calculator to figure out what 72 degrees is, and then you could just finish this problem, okay, with algebra, because we know that that's a number, that's 0.5, then we just solve for x. Okay, number 9. The Australian 50-cent coin has the shape of a regular Dodecagon, which is a polygon with 12 sides. One of these, right? Each of the 8 of these 50-cent coins will fit exactly on an Australian $10 note as shown. What fraction of the $10 note is not covered? Okay, so I guess that, basically what we need to do is we need to figure out the area of one of these dodecagons. Okay, and then later we'll need to subtract it off the area of the bill. So we can use the same strategy as before. Each one of these dodecagons is made up of 12 kind of pizza slice shaped triangles, okay? And then we can figure out the, let's see, we can figure out the angle of each of these, right? It would basically be, remember how we figured out that in the previous problem it was 360 divided by 5? Now it's going to be 360 divided by 12, which is quite an easy angle. It's 30 degrees. So each one of these angles here is a 30-degree angle. And to find the area of one of these pizza slices, it would be 1/2 times something, let's call it x squared, sine of 30 degrees. Okay, and let's see, another thing we know about this, this radius type number x is that, can you see the way the dodecagon is arranged? So like each one of these is actually, do you see how it's arranged so that like one of these lengths, you can figure out the width of the $10 bill by lining up 8 of these pink lines. So interesting. Okay, so actually, we could do something easier than that even. What we can do is, can you see how like we can divide each one of these into like a separate area into squares? So we can do that. So we're gonna inscribe the 50-cent coin into just a part of the $10 bill. And then, so we know that this thing across is 2x, right? We know that this is x, we know it's 2x across. So the total area is actually equal to 2x squared. And the area we're subtracting out is 1/2 x squared sine 30. And remember, sine of 30 is equal to 1/2. So we can just write, that this is actually 1/2 squared. And so basically we have 4x squared minus 1/4 x squared. Oops, and I'm sorry, each pizza slice needs to be multiplied times 12, because there's 12 of them. So it's actually 12 over 4 x squared, and 12 over 4 is just 3. So actually we have 4x squared minus 3x squared, which gives us x squared. Okay, so that means that the area that is not covered is x squared. So this purple area here is x squared, and the area that is covered is 3x squared. So this pink area is 3x squared. So what we could do is we could say that the area that is not covered is x squared divided by 3x. Divided by 4x squared, which is the total area. 4x squared. So that means the area that is not covered is 1/4. Okay? Interesting. I wonder if that's really true. This book, of course, was written in Australia. Can you tell by the problem they gave there? Okay, ADB is an arc of a circle with center C. So this is one of the circles here. This ADB, this arc, has center C and radius 7.3. So this here is 7.3 radius. AEB, we're going to draw AEB. AEB is an arc of a circle with center F and radius 8.7. 8.7. Okay. Find the shaded area. So the shaded area is this pink region, which is in between both. Okay. That is kind of a challenging problem. I think that one of the things we're going to have to do is we're going to have to draw a line here and then work with this watermelon shaped area. So we got this, and we got this line, and then we got the red line here. Okay, so let's figure out what these two watermelon shaped areas is, and then we'll just subtract them. Okay, because the bottom part of this makes it very complicated. I think we need to kind of get rid of that part. Okay, so let's do the red part first. So we'll do the red problem, which looks like that. The red problem has a radius of 7.5 and it's 100 degrees. Okay. We are trying to figure out what is the area of this section here. Okay, so basically what we need to do is we need to figure out the area of the pizza slice and then subtract off the triangle. Okay, so the pizza slice, since it's 100 degrees, this area is equal to 100 degrees divided by 360 degrees times pi r squared, which is pi times 7.5 squared. And then we're going to subtract off the triangle. The triangle is equal to 1/2 times 7.5 squared sine of 100 degrees. Okay, and so we're going to take this and we're going to subtract this. So let's see if we can simplify these a little bit. Since it takes so long to type numbers into the TI-84, the virtual TI-84, I'm going to do it offline. So I'm going to do 100 divided by 360. That gives me 0.27777. I'm going to multiply that times 7.5. Multiply by 7.5 again because it's squared, and then I multiply times 3.14, and I get 49.1. I'm going to just do that one more time just to see if I actually did that right. 100 divided by 360 times pi times 7.5. Oh, why do I always type that wrong? 100 divided by 360 times pi times 7.5 times 7.5. 49, okay, that's right, 49.1. And then what's the other one? The other one is, now I'm going to have to use a TI-84 because I need to figure out what the sine of 100 is. I don't know if it's still in degrees mode when you turn it off. I'll have to check that. Okay, it gives me a number very close to 1, so it looks like that's true, 0.985. Let's just check to make sure. 0.985, it's still in degrees. Okay, so the sine here is 0.985, and I'm going to multiply that times 1/2 and 7.5 squared. Okay, so 7.5 squared times 0.5 times 0.985. 27.7. Okay, so this red region, I'm going to find it by 49.1 minus 27.7, and that gives me 21.4. Okay, now I'm going to do something to find the blue area here, which is the exact same thing, except I'm just going to use a different radius, a different angle. Okay, so the radius I'm going to use is 8.7, and the angle I'm going to use is 80 degrees. Okay, so instead of 100 over 360, it's going to be 80 over 360, pi times 8.7 squared. That's going to give me the pizza slice shaped region. And the triangle shaped region I get by doing 1/2 8.7 squared times the sine of 80. And the sine of 80 is actually also 0.985 because those angles are mirror images of each other. So let's see, the top one 80 divided by 360 times pi times 8.7 times 8.7 is equal to 52.8. So this is going to be 52.8. The bottom one is going to be 0.985 times 0.5 times 8.7 squared. 37.3. Okay, so that's going to be 52.8 minus 37.3. You get 15.5. 15.5. Okay, so there is the blue region is 15.5, and the red region, which you can't really see because it's hidden here, is 21.4. So to find the shaded region, you do 21.4 minus 15.5, which is equal to 21.4 minus 15.5 is equal to 5.9. So the answer is 5.9. The region, this green region here, is 5.9. Okay? And that is the end of this section.